Hello guys, so today we are going to discuss a very important design pattern which is the part of microservice architecture. So while designing a microservice we have to consider few of the design patterns, so around which I have already have few videos which says for microservice there could be different design patterns. So bulkhead design pattern, today we are going to discuss about that. So let's consider what is bulkhead design pattern. So if we consider bulkhead design pattern, so what's the existence of this, how we are going to use this design pattern, what's the advantages, what's the challenges that we are going to face, some analogy that's going to be there to help understand better that this design pattern is going to be used where. So sometimes, let's take an example. So sometimes we built few components, as you can see in the diagram here. I'll come to the theory part later on, but here, if you see that with the bulkhead design pattern, if you see that if we have a bigger service that's going to be here, that's the red one, that's the red tag that's here, and the blue ones are the different clients. So if one of the client is giving overload to this service, and here without bulkhead it's going to impact the full service which is going to be there. So assume that we are not going with the service based approach, which is while designing a microservice, which is commonly used, referred when we are designing a microservice from a monolithic or the independent piece. If we are building, so that shouldn't be pretty much heavy, as a service. So, or like all the clients that are going to use that service shouldn't be that we cannot make a copy of that and provide the load balancing with a different copy of that service. So to start with, like what all that's going to be there as a part if we are going to go with bulkhead design pattern. So with when we are designing a microservice, which is we have built a microservice or we are starting a new microservice to build. So firstly, we have to consider that where this pattern is going to be used. So it's going to be used for fault tolerance. So we have like exception mechanisms while designing a microservice. So considering that into your account, so while designing a microservice, we have a fault tolerance mechanism. So how we can come up with, let's say, if there is chaos happened or there is fault happened within our microservice, so how we can come out of that fault. So this is how we can come out from that microservice or from a distributed application, thinking that if there can be multiple thoughts within those distributed systems, so how we can come out of that, what can be different ways, how we need to think for that. The question here arises that if we are building a microservice, so how can we make it a fault resistance or fault tolerant. So this design pattern here, it gives a bit of understanding that how to design a microservice which is more or less giving you the description that if you have heavily you know built a microservice and all the components are there in one of the microservice, then it's a totally dependent microservice, not loosely coupled. So it's heavily coupled with other services, interdependent. So our microservice has to be independent or loosely coupled so that the fault tolerance can be taken into account. and we can come out of that fault pretty much within a small span of time. So the important thing to notice here is there should be strategy while designing a distributed system. So once we have defined the strategy, so it's if we can think of some analogy, so it's kind of analogy. If we are building a big ship, then we have divided that, you know, if we are making it as a whole, then it would be a problem. Now if we have dissected that into different components, different segments, different areas from where we can, you know, integrate them whenever possible, and if we can, you know, enlarge the size or decrease the size as per our capacity, what the client wants or what the business wants. So based on that, if we are able to do, that is where this fault tolerance, if some of the chunks of the aircraft is, you know, is affected, then it's not going to affect the other component of that. It's not going to be a cascade effect, cascading failure that's there. So to understand it better, let's see this diagram to understand it, you know. So here in this diagram we have a service which is serving three clients, and it's serving multiple requests. And if the service goes down because of the heavy load which is coming from client A, and client B and C are going to be affected with the heavy load which is being put in by client A. So now with bulkhead design pattern, and we have loosely coupled services or independent service deployments, or maybe some other areas. So now if the client A is hooked with this service instance, which you can see over here, now service client B and client C are not going to be affected because of the heavily load of client A, and this is done through bulkhead design pattern. So we have independent service which are running and, you know, giving request and response back to the client based on their load, based on their timing, and this can be scaled as we have more customers. So this solution can be scaled. So this is not a scalable, this is a scalable solution. Now if this service goes down, it's going to come back again, and it's going to, you know, impact only client A which is putting heavy load, and it's not going to impact client B and C. So this is the basic functionality that we have to look at. Now let's take another example. So this is a normal flow that we are having here. If we have this green one and this yellow one, okay, so if the heavy load comes, then it's going to be distributed among these two. But if we have the heavy load that's going to come here and it's not scaling, that means it's going to distribute the load among the two, and we are getting some blocking request which is coming from, let's say, client A, and which is redirected to client C. So this chunk of code is going to be blocked because we are getting some requests which are being blocked over here. Now similarly, if we are not going to scale that, then other requests are going to be the part of B and it's going to impact there. Now to get the solution for that, now we have two HTTP client which are going to have their own resource pooling, and they are going to have a different set of resources or connection pools which are going to be there. So let's say if client C is going to be blocked, this block C is going to be impacted, then it's not going to impact block B. And this is how we are going to scale the things. So one client is not dependent on other client here, if you can see. So this is like through HTTP client, we can see that this also uses the bulkhead design pattern. Okay. Now, coming to some analogy, if we need to know that how the Java is behaving or itself, like in various area while designing the microservices, so where can we use that, or where Java has already implemented the brain, uh, like where it has already done that. So we can see in thread pool isolation, so we have different thread pools which are going to be there, and their isolation is going to be the integral part. So each thread is going to, let's say, have some set of payload, some request response. So every time it goes and create a new thread for request and response, and whatever the processing that it needs to do, it's going inside that thread. So it's going to be isolated, and it's not going to exchange data among each other, and like it's going to fulfill the requirement based on the thread initialization or the pooling size that's there on the web server. So now if we go and see, what's the next thing that's there. So it's isolation of request type. So if each request is coming, or one client is not going to be affected with other clients. So here, if one request is coming, so it's not going to be impacted with other request. So here we are safe. So while designing and keeping in mind that, if the server load goes high for one of the requests, so it's going to check through this design pattern. So now we have failure containments. So if one of the thread is going to be affected, then it's not going to affect the other threads. So it's going to make the fault tolerance. If one request fails, then the client can come with a different request, and it's not going to impact the other clients or other request. So similarly, it is resilient and redundancy, so that if each client comes, they have a limited shared resources. It's not going to increase in case of heavy loads and all. So this is one analogy, if we can think of in later in future, that how we can remember this. So we can remember this through HTTP server, how it is designed, resource pooling. These are the common example of bulkhead design pattern. Now let's come to the next analogy, which is our ship bulkhead. So let's say we are designing a ship from scratch, and then you know and it's going to go for a sail, or in a big river, in an ocean. So how we are going to design that as a part of, because that infrastructure of making that, and replacing that, if the if the if the ship comes from the sail, and then we need to replace some of the components, or if there is some issue with the components, so how we can deal with that. So let's say the ship architecture is the whole universe that we need to build, and how we can isolate that. So bulkhead is the isolated, how we can divide that into different chunks. Next mechanism is what, once we have decided that what's the isolation, or how we can tie those things, the isolated component, now we how we can tightly couple them once we reach to that level. Now if there is breach, that means if there is failure, so how we can rectify that. So all those things we need to keep in our mind. So redundancy is where, like, where we have so where we have lot many similar components coming together and doing a specific job. Resilience. So in case of resilience, it says that it shouldn't be a cascading effect. If one request, or we have this whole ship, so if there is a hole in the ship, then that piece or the component is going to be affected, not the whole ship. So this is the best or design that we need to follow. If there is some effect in one area, so the whole ship is not going to be sink, and we need to take care well in advance the thoughts which are there. Now let's take another example, which is the highways, how we are building our highways. So how we can, you know route the traffic from different areas which are coming. How we can have the lane management, the vehicles which are coming, the tolls which are coming, and more importantly, if there is some issue or there is some accident which happens in one of the lanes, so other lanes shouldn't be affected with that. Otherwise this will create a chaos within the system, that there would be a huge traffic jam. So that's why the lane based mechanism is there, so that let's say if there is some issue with one lane, while we are having our vehicle in one lane, and there is some issue with another lane, so that lane shouldn't be affected with the accident that happened in another lane. So that lane management, or there is some uh, work that is going on, that's there. So all those things can be taken care while designing the system. So it's more related to the bulkhead design pattern, where we are dividing the whole big chunk of uh, piece of thing into smaller component, and checking the fault tolerance, which is here. You can see that how we can divide that into different segments, into components, so that their exception handling mechanism can be taken care, and this shouldn't affect the other person, other client. So let's say there are different thousands or millions of requests which are coming, so those should be isolated from each other. Those shouldn't affect the requests which are coming from different clients. Those shouldn't be interchanged. Those shouldn't exchange the data between them, and those should be atomic operation that needs to be performed. And this is how we are going to achieve bulkhead design pattern. So keeping all those things in mind while designing our microservice, we need to keep this bulkhead design pattern in picture. So hope this video would help in understanding bulkhead design pattern. Thanks for watching.